Hey guys, welcome back to Michelle's STEM Journey. I'm Michelle and I'm here today with another AMC Problem of the Week video. This week's video comes from the year 2024, 10A, Problem 11, and it deals with algebra. I hope you guys enjoy this video and let's get started. The problem states how many ordered pairs of integers m and n satisfy the square root of n squared minus 49 is equal to m. So the first thing that we have to note here is that m is a non-negative number, and that's because m is equal to the square root of something, so m cannot be a negative. So m is greater than or equal to 0. And now we can start off by squaring and rearranging and just simplifying this equation. So by squaring both sides, we get n squared minus 49 is equal to m squared. And then I'm going to move m over to get n squared minus m squared is equal to 49. And then I'm going to apply the difference of squares here to get m plus m times n minus m is equal to 49. And it is clear that n plus m would be greater than or equal to n minus m. And that's because n can be a negative number, but m cannot. So therefore, even if n is a negative number plus a positive number is always going to be greater than a negative number minus a positive number. So basically, n plus m would definitely be greater than or equal to n minus m. And then we can factor out 49 to get 1 and 49. I'm just factoring out the pairs. 1 and 49, 7 and 7, negative 7, negative 7, and negative 1 and negative 49. 49 is not too hard to factor out. Okay, so we see here that from here we can get what m and n are each. So starting off with 1 and 49, we know that n plus m must be 49 because it has to be the bigger one. And the n minus m would be 1. So we can get m is equal to 24 and n is equal to 25. Because adding these two together will give you 49. And then subtracting n minus m is 1. So that is one pair. And then we get n plus m is equal to 7, n minus m is equal to 7. So m would be 0, n would be 7. And that's another one. And then n plus m is equal to negative 7, n minus m is equal to negative 7. We get m is equal to 0, n is equal to negative 7. And then looking at the last one, we get m is equal to 24, n is equal to negative 25. So these are all of the possible values. Now we have to see if they all match the circumstances. So the rule is that m must be greater than or equal to 0. So m cannot be a negative number. And we see that all of these satisfy that rule. So that means that there are 4 ordered pairs.